Quiz 6. So this first one, mechanism and products. So we start with an enamine, right? This enamine, right? One of the functional groups I talked about, new ones, enamines, imines, iminiums, those kind of things. So make sure you know what an enamine is. So what an enamine is when essentially you gotta be able to recognize that this carbon right here was a carbon of a carbonyl group, aceto-bondo, and that this part up here is actually the amine. So what happens is this kind of reacts like an enol. The electrons come down, and the pi bond reacts with the H plus. So it goes from an enamine to an iminium. But this is kind of a different way. So it's like a elimination protonation kind of step. It's kind of a different one. I say protonation here. Once you have this, now it's hopefully kind of clear. This is a little different than you've seen. Water adds, right? And if it's at the bottom, that means it's a solvent, so it's an excess. Water adds, get a tetrahedral intermediate, do a proton transfer because you know you need to get rid of the nitrogen. There it is. Do an elimination to kick out the amine part. And then we do a deprotonation with the amine to actually take the H. Right? You know that because this was there. So that's the basic steps. But what I want you to recognize is forward and backwards where these are coming from. We did 2 workshops on these specific ones, both this direction and also going this direction. So workshop 1. So for number 2, what I wanted people to recognize was this is an acetal. And acetals, the carbon of the acetal, will actually be a carbonyl, right? Because if you notice, this carbon right here is bonded to oxygen twice, 2 sigma bonds. So this is like that protection group. And eventually what's going to happen is this carbon right here, the water is going to add there eventually, and that's going to become a C-double-bond-O. That's what we get here when we get to this aldehyde. So this carbon right here is that carbon, right? Let's circle them. So that carbon is this carbon. And what I want you to always recognize with these ketals is, right, that carbon, the one that's bonded to oxygen twice, that's going to end up being a C-double-bond-O, whether it's an aldehyde or a ketone. So be able to recognize that first. Right, and then it doesn't matter here, this oxygen, which one takes the H plus first. It doesn't matter, right? So that doesn't matter which one falls off first, essentially. So here I had this one get protonated. Protonation, elimination, right? Be careful, right? Again, can you do SN2s? No, right? People, right? Don't do substitutions. This water can't add in here. It's too sterically bulky. Do an elimination, kick that out. Then do an addition, proton transfer, right? Elimination to kick that open now. You got the alcohol piece and the aldehyde or carbonyl piece, and then deprotonation to get to your final product, right? So this is kind of a weird one. This is kind of a little bit tricky because I want you to see that comes off, but then the alcohol and the aldehyde were actually in the same molecule, so that kind of made it a little more of a twist to it. But again, recognizing what that ketal acetal means. All right, number 3, a retrosynthetic problem. So again, let's always start out by, maybe trying to number some of these carbons. 1 and 2. 1, 2, 3, 4. So we need to add 2 C's, right? What else do I see? I see a carboxylic acid, right? I don't know how, I only know one way to make those with chromium from primary alcohols. I see the bromine on the less substituted C. So that's anti-Mark, right? Anti-Markovnikov. So that again, that makes me think, maybe Br2 and peroxides. And then again, I need to add C's. I start with the alkyne. So that usually means I'm going to have, right, this, then plus something with a bromine or however I want to do it. It doesn't have to be bromine, but there's a couple different ways to do this. So that's kind of my analysis I would start with. And the other thing to emphasize with these is there's always more than one. There's multiple ways to do these. This is just one way. And I saw a lot of creativity. That was awesome. So it's just one possible way. It's not the right way or wrong way. It's just one possible way. So what happens here? I took one step back and said, well, there's a carboxylic acid that must have came from our primary alcohol. Then I said, okay, now I got this OH and this bromine and the last substituted carbons. Maybe the bromine piece, right, came from an alkene, right? So if we're still numbering our carbons. Okay. So now how did I get an alkene? The alkene probably came from an alkyne, right? How did I add 2 carbons in an OH? Now this is where people got creative. I just looked at it as like, what if we just did an epoxide, right? So if we deprotonate here, we do an SN2, that opens it up, adds 2 carbons. Alcohol's on the less substituted carbon. Add H+, we get to this alcohol here. Lindlar's makes an alkene. Br2 peroxides, gets the bromine and less substituted carbon, and then oxidizing chromium takes the primary alcohol and makes the carboxylic acid. Just one way.